The dream, to achieve the full range of flight, to soar, to hover, to dive, and ascend. Throughout time, man has dreamed of many ways to achieve flight, to rise upward, to soar with wings extended. In this century, the dawn of powered flight began with fixed-wing airplanes. Others chose to rise with rotary wings, the helicopter. From that single dream to fly, the pathways of flight have diverged. The airplane has become the efficient, economical vehicle for medium and long distances. The helicopter, operating from small areas, has been the workhorse for short distances. The dream for some is to bridge the gap between the airplane and the helicopter. For them, the dream has never died. The dream begins to take shape in the early 1930s. One aircraft is able to fly like an airplane. Then the non-powered upper wing rotates for a vertical landing. In 1937, a heliplane is patented but never built, a craft remarkably similar to later tilt-rotor designs. At the end of World War II, many forward thinkers begin developing convertiplane designs and building prototypes. In 1950, the U.S. Air Force announces a competition to design a true working convertiplane. The McDonnell Company builds a compound helicopter known as the XV-1, based on a pressure jet plus a tip-burning rotor. But Bell Aircraft decides on a different approach, guided by the leadership of its chief engineer for the project, Robert Lichten. Under his guidance, Bell rolls out the XV-3 in 1955. Powered by a single reciprocating engine located in the fuselage, the first version of the XV-3 has 3-blade rotors mounted on tall pylons at the ends of the wings. During an attempt to convert from hover to forward flight, the XV-3 experiences violent vibration in the wings and rotors. After analyzing the cause of the instability, Bell modifies the design and tests a system mounted on shorter pylons. On December 17, 1958, the modified XV-3 achieves the world's first complete in-flight tilt-rotor conversion from helicopter to airplane mode and back to helicopter mode. Over the next 7 years, the XV-3 is tested by NASA, the Air Force, and the Army. In all, it performs more than 100 conversions between helicopter and airplane modes. During the same period, Boeing develops a test-bed vertical takeoff and landing aircraft. The Boeing VZ-2 is a tilt-wing aircraft that helps prove the VTOL concept. On July 15, 1958, the VZ-2 successfully converts from helicopter to airplane flight. In 7 years of testing, it achieves more than 200 successful conversions between helicopter and airplane modes. At the conclusion of government funding for the XV-3 program in 1966, 2 companies continued to pursue the dream of tilt-rotor technology, Bell and Boeing. During the late 1960s and early 1970s, Boeing conducts more than 3,500 hours of testing of tilt-rotor models, including hundreds of hours of wind tunnel tests. During the same period, Bell undertakes intensive efforts for a new tilt-rotor design. In 1972, NASA and the Army's Air Mobility Research and Development Laboratory award both Bell and Boeing contracts to begin new tilt-rotor designs. A year later, Textron's Bell helicopter is chosen to design, fabricate, and test a totally new tilt-rotor research aircraft, the XV-15. Utilizing modern turbine engines and advanced designs, the first of 2 XV-15s makes its first hover flight in 1977. Following extensive wind tunnel tests of ship number 1, the aircraft is flown and achieves full conversion to airplane mode in 1979. Over the next 9 years, 2 XV-15s test, prove, and display the reality of tilt-rotor technology by making more than 1,800 conversions, flying to 26,000 feet, and reaching a true airspeed of more than 300 knots in level flight, more than twice the cruising speed of a conventional helicopter. Near the end of the XV-15 program, Boeing designs and manufactures advanced composite rotor blades for improved useful mode and hover lift performance. By the early 1980s, the stage is set for the world's first operational tilt-rotor aircraft. A December 1981 document publishes the requirements for the Joint Services Advanced Vertical Lift Aircraft, or JVX program. The challenge is formidable. Compared to existing helicopters, the JVX tilt-rotor will be called upon to carry an equal payload at twice the speed over twice the distance, all at a lower cost. The two leaders in the field, Bell and Boeing, combine their expertise to participate in the Joint Services Program competition. It proves to be a winning combination. Bell's 30 years experience in tilt-rotor design and drive systems, Boeing's leadership in wing and fuselage design, fly-by-wire flight control, and advanced composite materials. Plus the success of Allison with its turboshaft engines for the military. On April 25th, 1983, the Naval Air Systems Command awards the Bell-Boeing team the contract for the preliminary design of the JVX tilt-rotor. Nearly 10,000 hours of wind tunnel testing are carried out, more than for any rotary wing program in history. The official name of the JVX aircraft is announced, the V-22 Osprey. In May 1986, the Navy awards a 7-year full-scale development contract to produce 6 flight test V-22s. Fabrication of the first flight test aircraft progresses. Nearly all wing and fuselage structural elements are fabricated from graphite epoxy composite laminates. The first V-22 fuselage produced by Boeing Helicopter is prepared for shipment to Bell Helicopter. As the first flight test V-22 aircraft is readied for rollout, the various integrated systems are installed. They include prop rotors with uniquely advanced airfoils designed for optimum performance in both hover and cruise flight modes. 2 fuel-efficient Allison turboshaft engines with a high power-to-weight ratio. And advanced avionics featuring glass cockpit instrumentation, a heads-up helmet-mounted display, and a digital fly-by-wire flight control system. From the beginning, the dream of tilt-rotor flight has never died. The V-22 Osprey represents the latest success in the persistent path toward achieving the full range of flight. But the potential is not yet fulfilled. Military and civil applications abound, both here in the United States and overseas. Future uses of the tilt-rotor are limited only by our imaginations. Today, the V-22 Osprey is adding a new dimension to the dream of flight. And tomorrow is just another dream away.
Honored guests, ladies and gentlemen, the Naval Air Systems Command, the United States Marine Corps, the Bell-Boeing tilt-rotor team, its hundreds of suppliers, and Allison Gas Turbine Division of General Motors proudly present to you and to the world the aircraft that will take flight to a new dimension, the V-22 Osprey.
Great concept, super future. We got
This is the CBS Evening News. Dan Rather reporting. Good evening. Bell Helicopter today took the wraps off its new combo aircraft, a fixed-wing plane that takes off and lands like a chopper. This latest future shock is supposed to change the way people get from here to there. Correspondent Peter Van Sant has a look at, maybe, the shape of things to come.
A revolutionary new aircraft premiered this afternoon in Texas, a plane with capabilities that once could only be found in science fiction. It's called the V-22, and like this prototype, it can climb and hover like a helicopter, then move its giant propellers forward and fly like an airplane, with a top speed of 363 miles per hour.
I'm convinced that in the next 20 years, there are going to be thousands of these type of machines flying throughout the world.
The Marine Corps has ordered more than 550 V-22s at a cost of $30 million each. But it's the peaceful use of the tilt rotor technology which holds the most promise. The builders of the V-22 hope it will eventually revolutionize the commuter airline industry, allowing aircraft to take off and land in downtown business districts, reducing travel time.
This will change the way we will fly short distances, because we no longer will have to use an airport to do our commuting.
In New York, commuters to Washington or Boston could take off from downtown Manhattan.
By the year 2000, there could be a market of 5 to 8 million passengers annually.
In remote areas, the V-22 would not need a landing pad.
In Alaska, we see this as a way to make remote communities in much of the bush part of our state very accessible.
The only question, is the V-22 safe?
Well, the safety concerns are always there, and that's why I think we'd like to let the military look at this, work the bugs out on the machine before you'll see it in commercial air transportation.
Commercial tilt-rotor aircraft should be available in 1995, giving some commuter airlines the option of telling major airports to take off. Peter Van Sant, CBS News, Arlington, Texas.